So rate law, ice table, and the Arrhenius equation, where you solve for activation energy. And this fourth type of problem is called the reaction quotient. All right, so here we're given gases, okay? So just on the exam Wednesday, if you're given moles, you're going to have to divide it by liters, okay? So in gases, you can be pressure, which is this type of problem. Gases can be in a pressure, like in this specific problem, or they can be in moles over a liter. So if you're given the moles and if you're given the liters, what will you do on Wednesday's exam? Okay, you will get moles over liters. And if you remember, moles over liters is big M. All right, so this is for gases. Okay, gases, moles over liter. Also aqueous, moles over liter. But for gases, we can have pressure, which is this problem I'm going to do with you guys, or moles over liter. So if you're given the moles, and if you're given the liters, what will you do? You will divide them on the test. Okay, moles over liters. All right, so this is molarity, and this is concentration, as we learned in our first exam. All right, so we have a reaction mixture initially at this pressure. So gases can be in moles over liters, or pressure. Here we have pressure. And these are the pressures of I2Cl2 and ICl. Find the equilibrium partial pressures at this temperature. Okay, so what will the final pressures be when this reaction goes to equilibrium? So how do we know this is in equilibrium? So how do we know this is in equilibrium? Okay, we always check our arrows. They have to go back and forth. That is in equilibrium. So is this at equilibrium? Well, the way to know if this is at equilibrium is that the Kp, okay, should equal to the pressure, because these are in pressures, ICl squared because of the 2 there, products over reactants, pressure I2 times pressure Cl2. So the way to determine if we are truly at equilibrium, 81.9, which is given to us in the problem, should equal to, what is the pressure ICl given to us? 0.1 squared. Everybody know why we square this, right? Okay. Because of the 2. Because of the 2, very good, Royce. Divided by pressure of I2 times pressure of Cl2. Okay. So when we find out that are we at equilibrium, the question is 81.9. What's 0.1 squared divided by 0.1 times 0.1? 1. So we are not at equilibrium. Okay. So which way does the reaction go to get to equilibrium? All right, so we're going to call this Q. Get another pen here. Okay, we will call this Q, we'll call this K. We will put Q first. And Q is 1, and this is 81.9. So the reaction is not at equilibrium. However, to get to equilibrium, which way will the reaction shift? To the right. Okay, the Gator rule tells us that it's going to move to the right. So reaction not at equilibrium. Otherwise, this would equal 81.9. We'll shift right to get to equilibrium. This is the Gator rule, if you remember. All right, so now we will use our ice table with this shifting to the right. All right, so I2 plus Cl2 to ICL. Okay, so initially we have 0.10, 0.10, and 0.10. Okay, that's I initially. Change, we said it's going to go, which way will it go? Okay, it's going to go to the right, okay, because of the Gator rule. So minus x, okay, plus 2x. Okay, so at equilibrium, this will be 0.100 minus x, 0.100 minus x, and 0.100 plus 2x. Absolutely correct, yes.
Very sure, sorry.
No, you're right. Good job again. Okay. So this is what we're going to plug in here. Solving for x, it has to equal 81.9. So 81.9 equals pressure of ICL squared, that's 0.10 plus 2x squared, okay, divided by 0.100x times 0.100x, that's squared. Okay. All right, so now we will solve for x. We will do that. I'm going to square root both sides. So what's the square root of 81.9? 9 point something, you're right. Square root of 81.9. 9 something. 9.0. I'll put some extra digits in there. 9.050 equals 0.10 plus 2x divided by 0.100 minus x. Okay. Excuse me. So we just square rooted both sides of the equation. Alright, so now we will solve for x. 9.050 times 0.100 minus x is equal to 0.100 plus 2x. Okay, let's see if you guys are okay in doing the math. I'm going to distribute. You guys know the distributive property. 9.050 times 0.1. Okay, 0.9050 minus 9.050x equals 0.100 plus 2x. Okay, everyone okay with this? Alright, I am going to, what am I going to do here? Okay, I'm going to move this 0.10 this side of the equation. I'm going to move the minus 9.050x. Okay, move it to the other side of that equation. So this becomes 0.9050 minus 0.100, just moving it across the equation, and 2x plus 9.050x. So this is a little math here. 0.9050 minus 0.1, 0.8050. We're almost done. 0.8050. 2 plus 9.050 is 11.050x. So last step here, x is equal to 0.8050 divided by 11.050. Is that right? Yeah, that's right. And what's our final answer here? .0728, .073, big M. I'll do three decimals. .0728, big M. All right, so at equilibrium, final answer, I2 is 0.10 minus x, so 0.100 minus 0.0728. .0272, big M. Okay, make sure you put the units in here because I know a lot of students don't put the units. The units are big M. Okay, what is Cl2? Okay, it's 0.100 minus 0.0728. Okay, it's 0.0272, big M. And then finally, ICL equals 0.100 plus 2 times 0.0728. .246, big M. Okay, so this is our final answer. Alright, so something like this on the test. Alright, so on the exam, you're going to have to do moles over liters, so make sure you divide them up together. Divide the moles by the number of liters. Okay, don't just put moles in here. Put moles over liters. Here in this problem, it's pressure. But on the test, you're going to have to take the moles and divide it by the liters. Okay?
When it says find the equilibrium partial pressure, is that unit ATM? Or if the question...
Oh, yeah, you're right. I'm so sorry. This is ATM. Yeah.
But when
My
it
bad.
asks for concentration, you put the molar.
Yes.
Okay.
I'm so sorry. You're so right.
It's a little confused.
Okay, yeah. Okay. Since this is an ATM, our final units are an ATM. But on the exam, it will be this. Yes. Okay. Thank you for that. Okay, so don't forget to divide moles over liters. Okay? And then on the exam, your final units will be big M. In this problem, because I just chose this example problem, it's ATM. Your final will be an ATM. Yeah, very nice. Thank you for that. Yeah, because they're in ATMs, on the final answer it will be ATMs. Okay, on the exam, your final answer will be molar, but don't forget to take the moles and divide it by liters. Okay, moles over liters. Because gases have this thing where they can be in moles over liters, molar, or they can be in atmospheres like we have here. Okay. All right, so that completes the computation portion of the exam. There is actually on the exam it's a lot easier. You just have to, on the exam it's much more easier. You don't have to do all this math on this exam. All you have to do is it at equilibrium, and if not, does it shift right or left? So you really on the exam just have to go up to here. Alright, on the test just up to here. Alright, so let's, there's another problem that is on Le Chatelier's principle. So there is, I think we went over some Le Chatelier's principle problems on the handout, which was a week before spring break, so just review that. Okay. All right, that's on Canvas. It's very similar to what we did before spring break. And then these are the rate law problems, so bring your rate law sheet to exam. Okay, so that will give you the equations, whether it's zero order, first order, or second order. This is basically plug and play. Right, this is plug and play, you know. So, like half-life is the example. Okay, so plug in the half-life, find K. Okay, this is just those types of problems. Okay, this is a first order half-life. Remember what half-life means?
The amount it takes for something to decay over time.
By how much? By 50%, half.
Yeah.
By half. Okay. All right. And one more equation that I'll give you where you plug and play is going to be this one here. This is first order. Okay, half-life is half-life. It's the same definition. But if that substance decays with second order, this is the equation you'll use. Okay. All right, so this is second order. So even though these equations are given to you, I would still bring the rate law sheet, though. If you don't have it, this equation will be given, this equation will be given, and it's plug and play. You guys know what plug and play means? Put it in and get the answer out. Okay? Plug and chug, plug and play. All right, the final thing I want to go over with are units of K, and this will be the last thing for the exam. Okay, units of the rate constant K. All right, so let's talk about the reaction A goes to B. All right, let's say A decays with zero order kinetics. So if A decays with zero order kinetics, or A decays zero order, all right, what will be the exponent here? 0. So what is anything to the power of 0? 1. So rate is equal to K. Okay, if this is zero order. So what are the units of K in this case? Okay, rate, what is rate? Okay, rate is like a speed. Rate is a velocity. Rate is a speed. But we don't use a speed miles per hour like we're driving in our car. Okay, customary units are molarity over second. Okay, that doesn't mean every problem will have these units for reaction speed. It could be micromolar over minutes, or I don't know, picomolar over hours. I don't know, but some concentration over time. But the base unit of concentration is molar. The base unit of time is seconds. Okay. So that is zero order. Okay, let's say A decays with first order kinetics. Okay, we have zero order, we have first order, and then we have second order. Okay, let's say this A, this reactant, decays with first order kinetics. Okay, so what will that exponent be? 1. Okay, it will be 1. So rate is equal to K times concentration of A. Okay. Anything to the power of 1 is that. So A to the power of concentration of A to the power of 1 is concentration of A. Okay, but what are the units of K now? Okay, this is all about the units. Okay, we mentioned rate is molar over seconds. Okay, what is the concentration of brackets? What are the concentration of these brackets? M, which is moles over liter. So we will take that K, isolate it by dividing by M, and this is going to be M over seconds. Bring it down, seconds. So for first order decay for this reaction, what are the units of K? 1 over seconds. You can do seconds to negative 1 also. That's perfect. Yeah. So this is first order. Same thing. All right, our final thing here is rate is equal to K times A. Now let's say it decays to the second order decay. What will that exponent be? Well, if it decays second order, that exponent will be 2. And so rate is equal to A decays with second order kinetics. Okay, so the rate customary units are, or the base units are molarity over second. K, that's what we need to find the units of. What is the units of the bracket? The units of the bracket are M, but what else is it? M, yes, M squared. Okay, so we're going to isolate K, and this is going to be M over seconds, M squared. Okay, do you guys see here that one of the M's and one of the M's cancels? Okay, so what is our final units of K? It's 1 over M, 1 over seconds. And yes, Royce, you can also say this, M to the minus 1, seconds to the minus 1. So this is if this reaction, okay, we're only talking about this reaction, not any other reaction. One reactant going to one product. Only this reaction. This will be the units of K, rate constant. So this is what we're interested in for the exam. So make sure you are good with that, and I believe that would be easy points. Okay, what is the units of reaction rate in general? Okay, units of reaction rate in general are molarity over seconds. Okay, it's kind of like the speed, but it's a chemical reaction. So this is molarity over seconds. But then, if this decays a certain way, the rate constant will have different units. Okay, rate constant will have different units.
For the test, will we have to be able to like write all of this out, or do we just have to put the units?
Just do this.
Okay.
Okay? So units of K, lowercase k, plug and play for these equations, but you can bring the rate law sheet. Le Chatelier's, just make sure you're comfortable with that. We had a lab and we went over a handout. And then once again, a rate law problem. Okay, a rate law problem. And bless you, an ice table problem. Okay, rate law problem. Number 1. All my stuff is so out of the way. Bless you. A rate law problem and ice table problem. An ice table problem, you do not have to do the quadratic, just square root both sides. A reaction quotient problem, but really you can just go up to here. Okay, a reaction quotient problem, and then a Arrhenius equation problem. Okay, remember the Arrhenius equation, finding the activation energy. right? So that's essentially your exam. Okay.
Do
All
we
right.
need to know how to write the rate expression?
No.
Okay.
No, you don't need to know how to write the rate expression. But that's, you take the inverse of the coefficient. Anyways, it's negative the
That's not
rate.
A, right? That's not, I get confused because when you're writing out the K, you put
They're
the
two different
coefficient to
things.
the top. Okay, that's different.
You do the inverse coefficients for rate expression.
Okay.
So the rate of change of the reactants are negative. They're going to equal to the rate of change of the products positive. The issue is when you have that, when you balance the equation, the issue. That's all. But there's no rate expression. Okay? Rate law is on the exam. Okay? This is like a 10-point problem or something like that. Okay? That is the exam. Okay? So a couple of announcements. I decided to go ahead and have lab today. So even though I did not cover it in lecture, I will cover it eventually. That's chapter 16. So we're still on chapter 15. So, but I decided I'll go ahead and do it. The reason why is that we have only 4 labs left. So once we finish this lab, which is kind of a long lab, but I wanted to get it done. Next week is a problem set, so really next week we don't have a lab. You just work from home. And then after that we have 2 more labs. So in the interest of finishing up faster, decided to have the lab. So make sure you, it's kind of a long lab, so make sure you read up on it as much as you can, okay? So that we can finish that up. And I didn't go over it in lecture, but I will. I'll go over solubility product constants in lecture whenever we get to that. All right, so a little behind, but I think it should be okay. All right, any questions on this test? Okay, rate law, ice table, Arrhenius equation, Le Chatelier's, why this is going to shift right, shift left, the units of the rate constant, and half-life. Okay, half-life. Okay, so make sure you're comfortable plugging it in and getting the answer out. Okay, so that is your test. All right, so let's just stop the recording.